Inequalities. Well, we need to look at the signs first. So if you want to say something is greater than, so if you're looking from, left to right, it's greater, like what's here is greater than what's over here. Well, all that means is, like I drew a number line here quickly. It means that if it's greater than it, it means it's further up the number line. So -2 is greater than -4 because it's further up the number line. The less than sign looks like that. So, if what's here is less than what's here. Obviously, if you're reading right to left, it's what's here is greater than what's over this side. And if you're reading right to left here, what's here is less than what's over here. So I'll just put in numbers so maybe you can see that a bit clearer. So 10 is greater than 4. It's further up the number line. And I'm reading from left to right. So 10 and the mouth of it is open towards the 10. So the 10 is greater than the 4. That's what that means. And then over this side, -6 is less than -2 because I'm reading from left to right. But if I was reading from right to left, it'd be -2 is greater than, because the big mouth is facing towards the -2. So the -2 is greater than the -6. So it just depends on which side you're actually like going from and towards as to what the sign means. So now let's just pick some true statements and do some true statements of your own here, and then pause the video and see what happens to them. So if you say like 4 is greater than 1. Now what happens if I add 3 to both sides? Like I'm just wondering, because we're used to dealing with equations. And the rules of equations are, you do one thing to one side, you just do it to the other. I need to see if these statements are okay, or these things are okay for inequalities, or does it change anything? So if I add 4 to this side, I get 7. If I had 4 to this side, if I had 3 to this side, I get 7. If I had 3 to this side, I get 4. Is this still true? Yeah, 7 is definitely further up the number line than 4. So yeah, that is staying true. So adding is not a problem. Adding in equations is the same as adding in inequalities. So no trouble with adding. If you want to, you could check a few more. Like what about some minus numbers? So -5 is further up the number line, or it's greater than -7. What if I add 3 to both sides there? So I end up with -2 on the left and -4 on the right. Is -2 greater than -4? Well, is it further up the number line? Yes, it is. So again, it looks like adding in inequalities is the exact same as adding in equations. I can just add the same thing to both sides and the statement remains true. What about if I was subtracting from both sides? So let's just take those two again. 4 is greater than 1. That was my original one, and I added 3 to both sides. How about if I subtract 3 from both sides? So on the left, I'd end up with a 1, and on the right, I'd end up with -2. Is 1 greater than -2? Yeah, it's further up the number line than -2. So yeah, that looks like it remains true, but let's check it out for these ones. Is -5 is greater than, so that was the second statement that I took. -5 is greater than -7. Let's subtract 3 from both sides. I end up, so I'm down, -5 minus another 3 is -8. Is that greater than -7 minus another 3 -10? Well, is -8 further up the number line than -10? Yes, it is. So it looks like adding and subtracting in inequalities doesn't make any difference. Like you treat it exactly the same as if you had an equation in front of you. So if you had x plus 5 equals 10, you just subtract 5 from both sides and you'd end up with x equals 5. You'd end up with a true statement. It's the same now for inequalities. If you have x plus 5 is greater than 10, well, then you can just subtract 5 from both sides. It doesn't affect the sign, doesn't change anything. So you subtract 5 from both sides and you'd end up with x is greater than 5. So what numbers are greater than 5? You know, like 5.1, 5.01, 6, 6.5. We've loads of numbers greater than 5. So there's loads of answers to that. X is any number greater than 5. And we see this all the time. You know, like let's say your answer was x is greater than or equal to 18. Well, you have to be 18 or older to get served in a pub in Ireland. So we're used to seeing this all the time, or at least hearing it. Maybe not actually seeing it written mathematically like that. But it just means you could be even a day over 18. You could be a week over 18. You could be 90. You could be 25. As long as you're over 18, you know, you're allowed you know, what the unknown is greater than 5. So anything greater than 5 is perfect. Anything greater than 18 or equal to 18 is fine as well in this situation here. So adding and subtracting is just like equations. You just add the same thing to both sides, no problem. Let's look at multiplying. So I want that number 9 there. So how about multiplying? Well, if I have, let's make a true statement, 7 is greater than 5. What happens if I multiply both sides by a 2? I'd end up with 14 is greater than 10. Is that true? Yep. How about if I had, let's say 7 is greater than 5 and I multiply by a minus 2? So I'd end up with minus 14 greater than minus 10. Is minus 14 greater than minus 10? No, it's not. Minus 10 is actually further up the number line. So that has changed the sign now. Multiplying by a minus number didn't allow the statement to remain true. I had to change that. Let's take another one. Let's just check that out again. So minus 2 is greater than minus 5. It's further up the number line. Okay, let's multiply. So minus 2 is greater than minus 5 because it's further up the number line. Let's multiply both sides by a minus 2. I end up at 4 and 10. Is 4, do I keep this sign? No, 4 is not greater than 10. So it looks like multiplying by a minus number in inequalities, I have to be very careful. I have to change the sign in order for the statement to actually be a true statement. So I started off with a true statement. I multiply both sides by a minus 2, and in order for the statement to remain true, I had to change this sign here. So multiplying by a minus number changes the inequality sign. So if you had x over 2 is greater than 10, it's okay to multiply both sides by a plus number. That didn't change anything. X is greater than 20. However, if you had x over 2 is greater than 10 and you wanted to multiply by a minus 2, I'd end up at minus x. That sign has to change and minus 20. And then multiply both sides by a minus 1 till I get the x. X is greater than. So remember, multiplying by a minus 1. So up here I multiplied by a minus 2 and I had to change the sign. Now I'm multiplying by a minus 1 on both sides and I'm changing the sign back. So every time you multiply, it actually works for division as well. Check it out for yourself. If you multiply by a minus number, you need to change the sign. If you divide by a minus number in inequalities, you need to change the sign. Is it possible then? So I'd like you to think about this. What if I want to multiply both sides by an unknown number? What happens to my sign? Can I do that? Can I multiply both sides of an inequality by an unknown number? Have a think about that and see